Vincent Legros, Marketing Officer for Mercator Ocean International. So on behalf of EUMETSAT, ECMWF and Mercator Ocean International, I am very, very pleased to welcome you to this first online WEkEO training focused on marine data products. I just want to share with you some numbers I could collect during the registration. So as you can see, we had almost 500 registrations for this event, coming from 70 different countries, mainly from Europe, of course. But we could see there is a very global interest in Earth observation for this training. As well, during the registration, you could express your interest, your area of interest in Copernicus service data. And almost 1/4 of you expressed an interest for all the Copernicus data and satellite products. And counting this 1/4, 73% of the registrants expressed an interest of 2 or more Copernicus core service data. It means that WEkEO is a platform needed for your activity, and we are very pleased to welcome you to this first training. So today, I introduce the speakers and experts. We will have Laurence Crosnier, Head of Marketing and Communication Department for Mercator Ocean International. She will do the first presentation, the overview, and she will give you the agenda of today. Hayley Ever-King, Marine Application Expert for EUMETSAT. We have Michael Schick, Data Service Engineering Team Leader for EUMETSAT. Laia Romeo, WEkEO Technical Manager for Mercator Ocean International. And our moderator today will be Marta Bertrand, WEkEO User Support Expert for Mercator Ocean International as well. So I just give you some basic rules for you, the attendee. So considering the huge number of attendees, you won't be able to speak. But at the end of this training, we will have a question and answer part. So whenever you express the need to ask a question, ask your question on the chat platform, bottom right of your screen. And you can see when you ask your question, you just add the question mark, and your question will be stored in the Q&A mode, where Marta, the moderator, will display the most relevant question during the Q&A part. Okay, the question will be displayed like that. I think I was very clear for you. I wish you a very pleasant training, and I leave the floor to Laurence Crosnier. We're going to give you an overview of the WEkEO DIAS service. Thank you very much, and enjoy your training.
Thank you, Vincent. Hi, everyone. Very happy to be here with you today. So let's start with a quick overview of the WEkEO DIAS service. First with the agenda we are going to have today. So I'm going to start with a short overview, a 10-minute overview of the WEkEO platform. Then I'll leave the floor to Hayley Ever-King, who is going to introduce you to the Jupyter Notebook Hub environment. And she will leave the floor to Misha and Schick, who is going to be introducing you with the cloud processing environment. Then I'll take the floor again to introduce you with the WEkEO product offer, so with more details about all the products. And then Laia Romero is going to take over for a Jupyter Notebook exercise. And then we are going to have a short question and answer session with you all guys. So I'm seeing some question about whether you will be provided with the recording. Yes, we will provide you with the video of this webinar. We will also provide you with many more videos on how to use the Jupyter Notebooks. We will come back to that later. And we are going to share all these resources, all this material with you through an email that you are going to receive just after this webinar. You are also going to be, all the questions you are asking right now through the chat, you will receive a written answer in the coming days as well. I mean, let's say in the coming weeks, because it usually takes quite some time to answer to you. So today is our first meeting with what we call this round 1 webinar. We are going to have another meeting in July 29 for a debriefing session. And in between, for those of you who want to use an exercise with the Jupyter notebooks you are going to be shown, you will be able to do that for free using all the videos and all the examples that Hayley and Laia and some other people have prepared. So in between today and July 29, you are going to have 2 weeks for exercising. And then on July 29, we are going to be discussing about all the problem you might have and all the blocking points you might have during those hands-on exercise. So I would like also to refer to other video we have on the YouTube channel, for which you have the links here. We had, beginning of July, we had a demo of the WEkEO platform, so that could be very useful for you to watch this video we made early July. And there are also some tutorial about the Jupyter notebook that Hayley made some days ago, some weeks ago, that you might want to check. So let's start with WEkEO. So WEkEO website is available at wekeo.eu. You can see a snapshot of the homepage of the WEkEO web portal, where you're going to find more information. So this is how to access the wekeo.eu portal. What can you get from WEkEO? So of course you can get data. All the Copernicus, the original Copernicus and Sentinel data are available from the WEkEO platform. As a reminder, the Copernicus program is the European Earth Observation Program. We will come back in more details a bit later about which data you can get, but basically you will get data allowing you to monitor the Earth, meaning the ocean, the atmosphere, the climate, the land, and so on, using satellites, using models, and using in situ data as well. WEkEO also provides you with computational resources, among which the Jupyter notebook, which we are going to talk about today. You can get free trials to use some of the computational resources and the virtual machines. You can also use the Jupyter notebook for free. You can use APIs in order to download the data. We'll get some more details about that. You can meet some of the experts about the data. And within the coming months, you will be able, through the WEkEO platform, to showcase your work and share and promote your work through our web portal. This is not available yet, but this will come very soon. So in short, what you can do with the WEkEO platform is to get a single access point to the Copernicus data and information. You can get processing resources and tools, and you can also, of course, get expert user support about this data. So which data we have? We have satellite data from the Sentinel, Sentinel-1, 2, 3, and 5P, and we also have the data from the Copernicus services, the climate, atmosphere, marine, and land services. Today we are going to focus on the marine data. So we have marine data on the satellite Sentinel-3. but we also have the Copernicus Marine Service, which also is focusing on the ocean, on the marine, and we have a few data on the climate about the ocean as well. So all the exercises you're gonna do today and within the two following weeks are going to concentrate on the Copernicus Marine Service data and the Sentinel-3 data. So what are the main assets from WEkEO? Last July 2nd, when we did the demo, there was one question about one of the participants asking why using the WEkEO DIAS platform, because as you might know, there are some other DIAS platform as the Onda, the SoBlue, and so on. So why using WEkEO rather than another DIAS platform? The three main reasons are here actually. First one is that the data which is on WEkEO is not a copy, meaning that you can access updated and timely Copernicus data from the original sources. So all the data, all the metadata and documentation, they are up to date. Because when you copy data, you might have a slight delay in copying the documentation and so on and the metadata. With WEkEO, it's not the case. It's really the original data, and you get it in a timely way. So this is very important point. The second point is that you can access the data using an API that we call Harmonized Data Access, which is a REST-based single protocol which allows you to scale and evolve your code. And it's really making your life more simple with using the data and processing the data. And of course, the third point about why using WEkEO rather than another DIAS platform is the expert user support, because WEkEO is built by EUMETSAT, ECMWF, and Mercator Ocean, and those three companies, they are involved since a long time. They have a lot of experience in the Earth's observation data and in the Copernicus program. So they really have expertise which they can bring to you through the user support. So we have two plans, one for free, which we call the Essential Plan, with which you can discover data, download the data, use some of the Jupyter notebooks. This is really going to be the focus today, Jupyter notebooks, and you can also exchange with the user support. And we also have the paid plan, which we call the advanced plan, which starts at €66 per month, where you can do all what you can do for free, but you can, on top of that, you can access to virtual machines, processing tools, and very soon you're going to be able to do some free networking. So you can get some free trials when using this, when applying for this advanced plan. So here are some more details about the pricing if you want to go for the advanced plan. So we have prices that go with what we call t-shirt size, depending on the number of virtual machine you need and the RAM memory you need. But you have those D-Lite, development, XS, small, medium, or so extra small, small, medium, and large sizes with different prices. So you can get free trials, and we are also implementing a pay-as-you-go plan where you only pay for what you are using. So in summary, this is what you can do with the WEkEO platform. You can, of course, search for data. This is free. You can download the data. This is free as well. This is really compliant with the Copernicus data policy. And if you register, you can also access to some of the Jupyter notebook and to the Jupyter lab. This is for free as well. If you want to use more advanced computing resources, you can apply for the advanced plan, and this is for charge. And you can also interact with the user support. So the user support email is support@wekeo.eu. So again, this is it's another way of seeing all what you can do, all the functionalities of the WEkEO service. So if you are not registered, you can discover the data and ask for the user support, and you can do that for free. You can also register, and you can, once you are registered, you can download the data for free still. You can process data with Jupyter notebooks. So this is free as well. And this is what you can do when you are registered. And then still when you are registered, you can apply for the advanced plan. So you start paying, and what you get on top of that is the access to virtual machines and tools. So a few short introduction, but I think Hayley just after me is gonna go into more details about that. What is the Jupyter Lab? It's really a tool which allows you to better understand how to work with the harmonized data access. It really allows you to test simple workflow for you to start working with the data, and it's really a tool for training we are going to use today. And Michelle is going to go in more details about that, but if you apply for the advanced plan and the cloud processing resources, you can you will be able to access the virtual machines through a dashboard or through SSH access. And Michelle is going to tell you more about that. So this is it for me. I'm going to leave the floor right now to Hayley, who is going to introduce you to the Jupyter Hub and to the Jupyter notebooks. Thank you.
Okay, thank you very much, Laurence. I'm just going to try and share my screen now so we can get started. Okay, so today I'm going to give you a brief overview of how to get started working with the WEkEO Jupyter Lab environment. This is going to be quite a quick overview, but I encourage you not to worry. We're providing a whole load of videos that will go through each of the bits that I will touch on here in much more detail, so you can revisit them at your own pace and make sure that you can access the tools and software and things that we're introducing you to today. But to start with, when you enter the WEkEO website, this is what you will see. To enter the Jupyter Lab environment, you need to be registered. So if you haven't done that, you can click register, but I have, so I'm going to sign in right now. Once you are signed in, you can find the Jupyter Lab environment under your dashboard. So if you then click here, you'll see on the left, there's a sign here called Jupyter Hub. To be clear, you'll hear Jupyter Hub and Jupyter Lab used interchangeably. They're kind of the same thing. They're just a different user interface for working with the Jupyter environment, which hosts programming scripts for you to use. So to instigate your version of Jupyter Hub, you need to click on this. I've actually already done this morning just to make sure that I was ready for the presentation and to make sure that we don't have any interruptions or to slow things down. So when you open your Jupyter Lab, something like this will spin up. You'll have the option when you click on Jupyter Hub there to select maybe a couple of different options. I would encourage you to choose the larger of the two options that you'll be given. For the notebook, you'll see the configurations are slightly different, and this will help you make the most of the tools that we've provided you with. So this is basically the Jupyter Lab environment. The first thing you see here in front of you is the launcher window. And from here, you can basically start doing various different things and using the different tools that the Jupyter environment offers. So the first thing I'm actually going to do, and this is the first thing you will need to do, is to import the code that we're going to work with. Now, you'll get the link in some slides that will be passed to you later, but we currently have our code for using the WEkEO Jupyter Lab on GitHub. It's here. This is what it looks like. So you can see, and you need to import this into your environment. There's a description of all the commands that I use in the slides that you'll receive after. But in order to run those commands, you need to open up the terminal environment. Click here. For those of you who are familiar with using a command prompt in your own computing work, this acts very similarly to what you're used to, effectively based upon things like Linux commands. So you can use the environment to move between folders, to delete files, etc. And here we're going to use it to execute some scripts. So I'm going to move now into the public folder. You start by default in this directory that you see on your left here. And from there, I can look and see what's here. In the public folder, you'll see that there's this one script that you can run. And this is the script that you need in order to move the code from our GitHub repository into your personal Jupyter Lab environment that you have on WEkEO. So to execute this code, you simply type bash wekeo -git clone.sh, and then in here you need to copy in the link from the Jupyter Lab repository that we have on our GitHub, which is this. I've already done this today, so I'm not going to run again now, but if you put that command in, you can open a notebook here, a blank one, if you want to write your own code, and you can also open an interactive console just to work in Python. At the moment, we just have Python in our Jupyter Hub environment, but you can actually use various other languages in this as well, and we may consider expanding this in future. But for now, all the examples that you'll see are based upon Python as a programming language. So once you've imported the repository that you need, you'll see in your main home folder here that you have this WEkEO Jupyter Lab folder. And that's just a copy taken from this GitHub of the code that we're providing you with. So you can open that here. I would highly recommend that you start with the Welcome to WEkEO Jupyter Lab Jupyter notebook here. You can tell it's a Jupyter notebook from the IPYNB extension, and double-clicking on that will open the notebook. This just provides you with a bit more orientation, as we're doing now, but in a bit more of a detailed way, and you can come back and refer to it about what the Jupyter Lab is, how it works, and how we've set it up. So you have an overview of that here, bit of description about the Python environment, including showing you what you've got here already. This is what you see when you first enter.
Hayley, please. 1 second. Can you stop sharing your screen and come back sharing your screen? We have some problem.
Sure, okay. Is that working better now?
Thank you.
Okay, no problem. Okay, so within this notebook then, you'll see there's a recap here on what I just showed you about how to clone the repositories in, and it tells you a little bit more about the different tabs that you can use here to help manage your Jupyter environment, to close down notebooks or instances of kernels and terminals that are running. This all helps you to manage the memory and space that you've got in this environment. So I'd encourage you to have a look at that and understand really what's going on behind the scenes with this infrastructure. The last bit here is some hints and tips, which builds on what I was just saying about managing the environment that you've got here in terms of memory usage. This is necessarily a limited environment because lots of us are going to be using this at the same time. We've designed the code that you've got here so that hopefully it can run fine in this type of environment for you. But a bit of good housekeeping, such as keeping your memory space quite clear, will help you to run your notebooks more simply and easily without risk of running out of resources to open images, etc. You can then also scale up if you're interested. So if you try this environment and you think, okay, I've got so far, but actually I need to be able to do this with 100 images instead of 2, you can then look at the virtual machines options to see how you would need to scale up your data usage in the WEkEO environment. But basically anything that you try in this sort of environment, you could easily move over to working in a larger hosted processing environment with our virtual machines. And my colleague Michelle will talk more about those in a later session today. Here we tell you a little bit about what the notebooks are and running them. So if you're not familiar with a Jupyter notebook, you have a couple of different types of cells. This here is a cell. You can see them up here. You have a code cell, but you also have cells which are known as markdown cells, which are basically written narrative. This is one of the really nice things about using Jupyter notebooks and this environment for training, is that you can combine really nice clear narrative and commentary with code that's actually executable in the same place. So it makes for a really nice teaching environment when you're introducing people to programming. You can also execute the cells when they're a piece of code. So you can't see one here. This is all markdown, but in the coming notebooks, you'll see by using the buttons up here, this allows you to run the cells. You can stop cells from running. You can cut and paste and add them and save, as you might expect at the top here as well. The last part of this introductory notebook explains the code that we've provided so far. So after you've looked at this, the next place to go is to understand the Harmonized Data Access API, and we've provided some scripts that will show you how to make calls to this API. I'll explain that a bit more in a minute because we'll have a look at that notebook. Once you've had a look at that, this is really the heart of WEkEO. I can't sort of emphasize that enough. This is what allows you to access all the various different types of Copernicus data that are out there and work with them in this environment. So this is a great place to start. The other notebooks that we've provided, which are in the Ocean folder and under 2 different folders, we'll have a look at those in a bit as well. These are all based upon using this Harmonized Data Access API to access the data that you need to work with in the notebooks. So start from this notebook, the Welcome to WEkEO one, move on to looking at the Harmonized Data Access API. And after you're done with that, you can explore some of the different thematic notebooks that we've provided. Of course, if you need any help, in general, you can get help through the WEkEO support, but during this training course, we've also provided you with a chat form that you can use to contact us. So if you have any questions about these over the next couple of weeks, you can use that. We'll provide the link for you with the follow-up materials for that. So that's the introductory notebook. For now, let's do as I suggested and have a look at what's in the WEkEO Harmonized Data Access API folder. So I've moved now from WEkEO Jupyter Lab into WEkEO HDA, and you'll see in here there's another notebook. And if you double click on that, it will open. And this is a more full example of a Jupyter notebook. So we've got some markdown text and descriptions here, which I would encourage you to always read, because these notebooks are designed to be self-standing, so you can follow them through yourself and read as much as you need to follow the additional links to get information, etc. And the commentary around the different code cells explains really what's going on. I don't have time to read all this for you now, and I'm sure you wouldn't want me to anyway, but please do read this through in your own pace and understand and ask questions if you have them. So the first thing we do with any Jupyter notebook is we have to load in the required libraries for our Python environment that we're using. So that's usually the sort of cell of code that you'll see at the top of all the notebooks that we've got here, and indeed in any piece of Python code normally. As I said before, to execute a cell, to run the code, you can click on it and then you can press play, as here, and you'll see now that the number changes in this little box, and that means the code has run and executed. So I've just imported a load of libraries here. If there was any problems with this, you'd see errors that would appear below. So if you have any of these that appear during your time working with the notebooks, I would suggest you copy these into the chat form when you send us a query. That will help us to understand what's going on with your particular activities on your notebooks. Within then the rest of the notebook, we load in some more functions. So these are the particular functions we use for the Harmonized Data Access API. I'm not going to execute all these bits of code as we go through. I've already pre-run this for you, so you can just see what happens without having to wait. But each of these is explained, as I said before, by the narrative. So here we're loading in the HDA functions, which is crucial for this notebook and indeed all the ones that we're using here. After that, the next section of this notebook moves to look at how you can search for data sets on WEkEO. And if you've never used the WEkEO web portal before, I would recommend watching the previous webinar that Laurence mentioned, which shows you how to use the interactive data portal. This allows you to search and see what data is there in an interactive way. And it also provides you essentially with the access to the metadata information that you'll need to construct the harmonized data access API queries that we're showing here. And from that, the key thing you need really is the dataset ID. So in this notebook, we're looking at a particular set of data. This is OBJECTIF level 1B full resolution data from Sentinel-3. This is ocean color data that's been not yet been atmospherically corrected, for those of you who are familiar already with this type of data. If not, there's lots of information in the catalog for you. And its dataset ID is this, as you see here. And you can get that information within the interactive catalog here. We've entered this in our script in this box here. The next thing you must do in order to access WEkEO is to input your user credentials. So in the notebook here, although I've already run it, I've subsequently taken away my username and password so you don't all know it and use my account. You'll have one of these for yourself if you've registered. So in this section of the code and in all the subsequent notebooks you look at, you would need to change the username and password here to your own, and remember that it needs to be in the quotation marks. This allows us to generate the keys and tokens that you need to access the API and give you permission to search and then download data. So after this section, we then initialize a request to the API. It's all explained here with the different functions that we use to request access, accept terms and conditions, etc. After that, we load what's called a data descriptor file and then request the data. So the harmonized data access API requires a JSON file in order to describe the data that you're looking for, and this is how it makes its query. In principle, it's a dictionary if you're familiar with Python, and it includes some key information here. You can get examples of these from the interactive web portal when you're searching and you're looking, for example, at OBJECTIF level 1B data here. If you click Show API Request, it will give you an example of a JSON file for working with this data, and you can cut and paste that in to use it here. In this part of the code, we load one of those files. You can also predefine it here yourself if you'd like, so you can actually change the dates that you want to select for, the bounding box that you want to search over, the product type, etc. yourself in here if you'd like, if you know them already, or if you're doing this in a programmatic way, you could actually write a piece of code around this to automatically replace it. This is how you would access the data if you were scaling up your application, for example. But for this notebook, we've tried to make it step by step, so you just understand what's going on in the process. After that, we initiate the request here, which assigns a job ID to launch the search. As you can see here, when you run this, you get some output, which tells you that the query has been submitted and is running. This will keep going while this is running. Once it's found some results, you get those reported back from this function, which will show you here that we found a particular OBJECTIF level 1B product that we were interested in for that specific date, time, and region. This next section then creates the order ID, and this is what you need then to download the data. So the final block of code here initiates that request to download the data. It tells you then where it's downloaded to. You can specify this at the top of the script, and it will tell you while it's downloading how it's progressing. This is a little bar that moves across. It'll tell you how fast it's going, what size it is, etc., and eventually tell you when it's complete. So when you have this code for the first time in your Jupyter Lab environment, none of this will be run, and you won't see the little bits of output that I have here. So you'll need to add in your username and ID, and then you can work through and run each section of the code. And at the end, hopefully what you will have is an OBJECTIF file that appears in this directory here, as I have. So this is just one example of using the WEkEO Harmonized Data Access API. Once you've got it running for this example, I would highly recommend you go and try and do run the same piece of code, but for a different type of data that you're interested in, and see if you can download it. Once you're done with this, you can then move on to the example code, and I won't talk too much about these because Laya's going to demonstrate them later. But under the Ocean folder, you'll find a variety of different scripts, different Jupyter notebooks here, again with that IPYNB extension, which you can use to understand what's how the Sentinel-3 data works in this example, in these set of examples here for the 3 different instrument packages. Or if you look under case studies, you've got a variety of different applied use cases of the data. So we've got some for using Sentinel-3 data, some for Sentinel-3 and CMEMS data, and some CMEMS model and merged satellite data here as well. And these are all, as I say, self-explanatory once you're in there, and you can use the same principles from running the HDA notebook in these. So for now, that's all I wanted to show you about the WEkEO Jupyter Lab environment. As I said before, we'll be providing you with more videos, and we're here for your questions as you work through these examples over the next couple of weeks. So with that, I'm going to stop sharing my screen. And I think next I need to hand over to Michelle, who's going to tell you about how to scale up your use once you've had a go with the Jupyter Lab to use the cloud processing environments more fully. Thank you very much.
Good morning, everybody. I hope you can see my screen. And on my screen, I want to show you how to manage your virtual machines. Laurence mentioned before about the advanced plan and how you can obtain sort of the virtual machine environment. So once you're registered on WEkEO, there's the option to register for an advanced plan. And as part of the advanced plan, you get a free trial for a couple of months. And within the free trial, you can manage your own virtual machines. The virtual machines are similar to what you might know from Amazon, where you can get a cloud computing environment. So in principle, Linux workstations or boxes that you can access and do for your computation. On the WEkEO website, once you signed in, I do this now as a user I have. You have a dashboard. When you click on the dashboard, you find the access to the virtual machines under the link Virtual Machines. If I click this one, I will be guided into a dashboard. So it says on top Morpheus because the product is based on the COTS Morpheus. And within this tool, you can administer yourself your virtual machines. You can create one, you can stop, you can manage your users and all the kind of things. One of the first things you would do at the beginning is you click on your username and you go to user settings. Within the user settings, what you do is for your Linux account, you provide your username and a password. And this is the username and password which is injected into the virtual machine. So you need this to access your virtual machines later on. There's also the option to upload SSH keys. They are shown here, but you have to go to towards infrastructure and go to keys and certificates. And here you can add your own SSH certificates and you can upload the key pairs. And those ones can be specified and will then be available within the virtual machines. Going over, you click on provisioning and instances. And under instances, you see the number of virtual machines you're already running. So here in my case, I have a total of 7 virtual machines. They can be of all different kinds, yeah, like Ubuntu, CentOS, whatever. You can bring as well your own images and upload. I show you now how you create your own virtual machines, how easy it is. You click on the button Add. Then you can select normally of a preset of images that we have prepared. This is not the complete list, but you see here it on the example of Ubuntu. You click then Next. You have to provide an instance name. So I type now something in, WEkEO Demo 2, for example. You select an environment. It's only a tagging. It doesn't matter whether you set it to development, test, or staging. And then on the next step, you have all the options for your virtual machine. You can choose from the plan. Here you see the default is X Medium. It has 12 cores and 92 gig of memory. But you can choose between whatever fits in your plan and in your subscription model. For the sake of ease, I use now here an extra small. It has 1 core and 8 gig of memory. You can manage your volume attached to the virtual machine. You can as well within Morpheus manage your object storage buckets and also have a shared file system. But within the short period of time we have today, I don't go into such detail, but I show you later on where you find the information. I select here a local network. availability zone Nova, default security group, and I can select an external, an external IP. The floating IP external is important here because then you access from your home environment via this external IP, you can reach the virtual machine. If you don't select an external floating IP, then the virtual machine is reachable within the network available. You see now here, this is a summary of the complete workflow. So this is the instance name. It's Ubuntu extra small. It's Ubuntu 18.04, and it has 20 gig of volume. And if I click now here, completion, the image will be created. So you see it down here. So it's in the status of provisioning, and I can follow up the creation. It takes normally a couple of minutes. You see here on the progress that it's going up. And in a minute, we should be it should be ready and usable by us. I show you then in the meantime from the WEkEO web portal. By the time this is finishing, on the WEkEO web portal, we have documentation section. If you click on the guides, you see here are a lot of help regarding the different things. So what I showed it to you is creating and accessing an instance. You can add then your own users from your own organization. You can create Morpheus user accounts and allow others of your organization or share friends to access the virtual machine. There are tips how you manage security groups if you want to open specifically ports. There are information of how you use, for example, object storage if you want to store computing results in object storage, or if you have several virtual machines and you want to use a shared file system. So under these guides, you find step-in-step instructions how to do this. So for example, if you look at this one, creating and accessing an instance, it shows you exactly what I showed you before. Now I go back to the dashboard. Let's see how far this is. This instance creation has now not worked because maybe I have used up my external floating IP addresses, but it doesn't matter so much. I created one before. So I show you on another example. What you can do is here as well in Morpheus, you can access the console. And on the console, I can normally log in then with my username and password, and this is your Linux terminal shell. What you can also do is, additionally, you can create a remote access environment like a Linux desktop. But for that, what you have to do is you have to install after the VM has been provisioned. I go back to the guides. And you find it under using a GUI on virtual machine with Linux. And here what you can do is after the virtual machine has been provisioned, you can install tools like you can connect with X2Go or Mate, and you can have then at the end your Linux desktop. But within the 10 minutes, it would be a bit too short to show you that. And then you can access with the provisioned external IP using the remote applications like X2Go or Maze, and then you have your Linux desktop environment in your own organization. On Morpheus itself, you find the options regarding the management of the object storage. You find it under the infrastructure here. You can find then that under storage. That's for the shared storage and the object storage. The keys were here. You can have a dashboard where you can look at the overall amount of VMs, etc., that you use. And under provisioning, you can upload as well under virtual images your own images. If you have created in your organization or so, if you have your own virtual machine, you want to bring it and upload it in WEkEO, that is also possible. So this is roughly what I wanted to show you today. And I would stop sharing the screen and pass over to Laurence.
Thank you, Michel. So I'm going to take over now and provide you with more information about the products, the data products that we have in the WEkEO catalog. So as mentioned before, we have all the Sentinel satellite data from Sentinel 1, 2, 3 up to 5P. And we also have data from the Copernicus services, from the climate monitoring service, the atmosphere monitoring service, the marine monitoring service, and the land monitoring service. So I'll go in more details with all this data. So the Copernicus Marine Service data is coming from the Mercator Ocean International Data Store. So I'll go into more details in a minute about that. The climate change monitoring and the atmosphere monitoring data is coming from the ECMWF data store. The land monitoring data is coming from EEA and JRC. Then we also have Sentinel-3 marine data, and very soon it's going to include atmosphere data. So those Sentinel-3 is satellite data, and it's being stored in the EUMETSAT CODA. It's coming from EUMETSAT. And we also have Sentinel-1, 2, 3 land and 5P satellite data coming from ESA. So all those data from the Copernicus program is within the WEkEO catalog. And we have dedicated connection to the original data, meaning that we do not have copies. So for the Copernicus Marine, Copernicus Climate and Atmosphere, the data we have are not copies. They are directly the original data. And it's the same for the EUMETSAT data, the Sentinel-3 marine data as well. For some of the data, like the ESA data, for example, those are copies of the original data. So today we are going to focus with the Jupyter Notebook on using the marine data. So from the Copernicus Marine Service, some of the Climate Change Service marine data, and from the Sentinel-3 marine data, satellite data from EUMETSAT. But I'm going to detail each of those catalog, starting with the Copernicus Marine Service. So what do we have within the Copernicus Marine Service? So we have data about the blue ocean, which is about temperature, salinity, waves, currents, and sea level, for example. We also have data about the green ocean, meaning acidity of the ocean, turbidity, nutrients, and some of the living resources like phytoplankton, zooplankton within the ocean. And we also have data about the white ocean, meaning sea ice. All those blue, green, and white ocean data, they are coming from different sources, from satellite, from in situ, and from models as well. And in terms of spatial coverage, they all cover the global ocean, but also European basin. We have dedicated product for the Arctic Ocean, for the Baltic Sea, for the Med Sea, the Black Sea, and the Atlantic Ocean, the North Atlantic and the South Atlantic. And in terms of temporal coverage, we cover the last 25 years up to today, including some forecast, because the model that are provided allow to provide with a 7 to 10 day forecast. Satellite data and in-situ data do not allow that, of course. So in more details, I'm not going to spend too much time on that, but as I was saying, for all the basins, for the Arctic, the Atlantic Northwest Shelf, European Northwest Shelf, the Atlantic, Iberian, Biscay, and Irish Seas, the Baltic Sea, the Black Sea, the Med Sea, and the global ocean, we have satellite data, in-situ data, and model. either in the past or in the present time, and for some of them in the future with the forecast. And they are all about sea surface temperatures, sea level, ocean color, waves, or wind as well for the satellite. They are about the ocean physics for the in situ. We start to have some biogeochemistry data for the in situ, but it's going to grow in the coming years. And for the model, we have data about the ocean physics, the ocean biology, and the ocean waves. So this is a summary of what we have for the Copernicus Marine Service. Now, if we go to the Copernicus Atmosphere and Climate Change Services, we have for the atmosphere data covering regional basins within Europe. We also have global data. Those over Europe are near real-time air quality analysis and forecast. There are also reanalysis in the past, which are being updated every year. For the global product, you have near real-time analysis and forecast. You also have reanalysis in the past. We have also supplementary products which are addressing policies in order to answer European directives, for example, and the greenhouse gas flux inversion, the climate forcing, solar radiation. And then we have emissions products, including anthropogenic emissions, fire emissions, and natural emissions. So all those data, they are included in the atmosphere data store, but they are also available from the WEkEO through the Harmonized Data Access API. Now, for the Climate Change Service Catalog, so there it includes in situ and satellite-based observations with all the essential climate variables like temperature in the atmosphere, sea ice parameter, and so on. It also includes climate reanalysis, including the ERA 5 reanalysis for the global and regional areas. It also includes multi-system seasonal to interannual forecast and climate projection, like for example the CMIP5, the Codex Regional Climate Model Data. All of this data is available from the Climate Data Store and also from the WEkEO platform through the Harmonized Data Access. Now, if we go to the Copernicus Land Service, it includes also global pan-European data, on top of which you are going to find imagery and reference data for parameters like land cover and land use mapping. So you have a few parameters which are being proposed. It's not exhaustive. This list is not exhaustive, going from land cover, leaf type, forest type, and so on. You have also what is being called hotspot monitoring, including delineation of riparian zones, urban atlas change, urban atlas street tree layer. You also have biophysical parameters, including high-resolution fractional snow cover, lake ice extent, for example, leaf area indexed, and so on. You have imagery, in situ, and reference data, and also European ground motion service. So another way to look at the portfolio from the land service, among the global data, you are going to find mid to low spatial resolution data, including allowing you to monitor the vegetation, the water cycle, the energy budget, and the terrestrial cryosphere with vegetation, energy, water, cryosphere, hotspots, and ground-based entry. Then for the pan-European basins, you are going to find higher resolution data, including the marine land cover, the high resolution layers, the biophysical parameters, and so on. And on top of that, you will find imagery and reference data, including the EU DEM and the EU hydro systems. Now, if we go to data which is coming from EUMETSAT, which is the satellite Sentinel-3 marine data, it's covering level 1 and level 2 global data in different latency modes. So depending on the sensor you are looking at, you are going to get different parameters. If you look at the altimeter, you are going to get altimetry data. If you are looking at the OBJECTIF instrument, you are going to get ocean color data, including chlorophyll or total suspended matter, for example. If you are looking at the radiometer, SLSTR, you're going to get sea surface temperature. And it also can provide with some atmospheric composition data. So you have in this table some of the latency modes which are being provided for all of this data. And finally, the data coming from the ESA hub, which is Sentinel-1, 2, 3, the land part of Sentinel-3 and 5P. So it includes all the Sentinel-1A and Sentinel-1B, the Sentinel-2A and Sentinel-2B data from the MSI instrument, the Sentinel-3A and 3B, so it's only the land part here, it's also including the marine part, I think, but we have both the land part on the one side and the marine part on the other side, and the Sentinel-5P from the TROPOMI instrument with parameters which are listed here, for example, like aerosol index, albedo, and some of the tropospheric profiles from the TROPOMI Sentinel-5P. So here is the details about the offer, the data offer we have on WEkEO. So all this data is available through each of the Copernicus services, but also through the WEkEO platform, through the WEkEO catalog. So now I'm going to leave the floor to you, Laia, who is going to show us an example of a Jupyter notebook. Thank you. So no, Laia, we cannot hear you.
Laia, I will log out you and log in. Hayley, for the time being, maybe can you take over?
Yes, that's fine. I can take over if needed. Okay. Share my screen again.
Hello?
Okay. Just checking you can see my screen now.
Okay, Laia is back actually. I can see her.
Okay, that's fine. I'll stop sharing.
But can you hear me?
Yes, we can hear you.
Yes,
No.
perfect.
I don't know. I don't know what to do.
Yeah, we can hear you very well. Huh?
Sound is back. Okay,
Yeah.
so you do hear me now.
Yeah, we can.
Okay. So I start. As we were saying, and my colleague showed, once you are signed in the catalog, you go to the dashboard, to the Jupyter Hub, and you access the Jupyter Lab. We showed it before, but I see some questions about this. In this case, I'm going to show the marine use cases that we prepared for today.
Laia, one second, please. Can you hear me?
They should open here too, but just in case. Okay, so we have a couple of notebooks. I will show you.
Can you hear me, Laia? Laia?
Can you hear Vincent?
Yeah, this is not the right...
in this notebook, we have different exercises. One is about the data and how we access it, the Python modules that we do, how we interface with this, and an exercise, a practical exercise on plotting time series of partial pressure CO2 over the sea surface and actually over the ocean in general.
Okay.
So
Laia,
this is a notebook that we prepared at Mercator Ocean. And if we go, and this is available for you as an example.
We had some problem of screen sharing with Laia. Maybe Hayley, can you share your screen if you don't mind? And I will.
Yes, I can.
Laia. Thank you.
Yes, I can do that. That's fine. Okay, can everybody see my screen there?
Yeah, perfect.
Okay, great. That's okay, no problem. It's a difficult environment working online, and it's particularly difficult doing live demonstrations, so we have flexibility. So I think what Laia was going to show you was some of the case studies that we are providing. So I'll show you one of those that I know quite well. So within the Ocean folder you've got here, you've got two different sets of folders that have some example notes, as I mentioned before. In this one, there's some introductory notebooks for using Sentinel-3 data. So if you've never worked with the data before, or you just want to refresh, you could open one of these to have a look. For example, this first one here looks at ALTI data and allows you to make a quick plot with it. Just wait for that to load a second. Here you go. It will basically show you how to load the data, and this is a load of skills that are useful for working with various different types of data. It will refresh you on how to access the data through the API. In this case, we're looking at the Sentinel-3 ALTI level 2 data, so building on what you may have seen with the level 1 data in the harmonized data access script. Shows you how to do that download. Scroll through here. Are you familiar? And it shows you how to make some quick plots. Very, very simple one, which we'll probably agree don't look so great. Then it works through in each of these sections how to subset some of the data, and finally how to produce much more meaningful and interpretable plots, which are, for example, geolocated on a proper map. And have flags applied. So this image here just summarizes what you would get if you geolocate the data onto a map display using the CATALOGUE library in Python. And then the last one here, after some work above, applies flags to the data. So it shows you how to get the highest quality level out of the ALTI level 2 data there. So you could apply this in principle to any other type of spatial data. A lot of the plotting commands will work with other data forms as well. So that's just one example with ALTGE. As I said before, there's a similar thing for the SLSTR. If you want to look at sea surface temperature data, shows you how to apply the flags there. And the same with the SRAL altimetry data. This is a different type of data with it collects data along track in a narrow sort of line. If you've ever seen altimetry data, it looks very different to the optical data if you're used to working with that. And from the complex series of echoes and waveforms that we get back from the altimeter, we can derive various different products. And that notebook will show you a bit about how the tracks look, but then also what the waveforms are like, and how that tells us about what we're actually looking at in terms of whether we're looking at ocean, whether we're looking at ice, whether we're looking at land, and how we can derive products such as information about waves or about sea surface height from this data. So that's the simple set of introductory Sentinel-3 notebooks that we've got. And then we also have some other case studies. So, sorry, let me just go back to that. If you open the Ocean Case Studies folder, there's 2 notebooks here. I think this was the one that Laia was going to demonstrate. I'll open that one to show you. This shows you how to work with some of the products from the Copernicus Marine Service. This data is different again to what you'll get from Sentinel-3 in that you, as well as having the surface view, you also have depth based information because this is from a model, and you also have multiple parameters that you can look at and to compare. So this notebook shows you how to, again, get that data through the HDA with a set of different Python modules or libraries that we use. And if I scroll down, you can then see that you can conduct an exercise to plot a time series, looking in this case at CO2 fluxes, and various other time series. There's the CO2 one. There's a couple of other ones that you can trial as well. Same with the other notebook. Looks at a couple of different parameters and allows you to plot them in different ways. See if that will load. There we go. Yep. So this follows on in a similar way, looking at other data products. Again, shows you how to download them. Of course, this is the essential part of, I think, learning to use WEkEO. Further down, you can look in this case at phytoplankton carbon biomass and chlorophyll, as well as primary production and oxygen. And the latter parts of this script actually plot some transects of these variables. I haven't run these, but you can do that when you're in the interactive environment. Lastly, we have 2 examples using Sentinel-3 data, or 1 example using Sentinel-3 data and 1 example using Sentinel-3 and CMEMS data together. This script here is a nice example of using ALTGE data that we've looked at already a couple of times to produce a very nice red, green, blue or true color type image, something commonly people want to do with satellite data, to look at a case where we had a huge cyanobacteria bloom in the Baltic Sea last summer following the European summer heat waves. So I won't go through this exhaustively, but again, you've got your HDA access in here. It tells you a little bit about how to set up the different channels that are within ALTGE to extract the data from the netCDF file and set up a red, green and blue channel using different coefficients to make a nice true color type image, and how to adjust that. So this is quite a nice skill to have if you want to create true colors of any imagery this could be from ALTGE of any location, whether it's ocean or land, or if you're interested in atmosphere. This is generally quite a nice method to understand. You can also do it with Sentinel-2 as well as Sentinel-3 data. And finally, you end up here after you implement those things with a really nice true color image of this particular cyanobacteria bloom in the Baltic Sea. There's also various links in here which will tell you more about this event, why it happened, and what we can learn about it from space. The final example we have here is on marine heat waves. So this is a phenomena where we're looking at similar to heat waves on land, but looking at extreme temperatures in the sea. And this builds on both SLSTR and CMEMS time series of sea surface temperature, and uses some freely available code libraries from experts in marine heat waves to show you that you can use this data to extract information about how likely an event is that it could lead to a marine heat wave. So we look first of all in here, once we've done the downloading, we plot some SLSTR data to take a detailed snapshot of what's going on in this specific area. then further down, we start looking at time series of sea surface temperature data. This is another notebook that I haven't pre-run for today, but when you click and execute these, you'll be able to step through and see the outputs. You can then look at a time series and apply a bit of an analysis that shows you how far above sort of a longer term average the current temperatures are, which can give us some hints towards whether we might be experiencing a marine heat wave in a specific area. Interestingly, this script also generates kind of a climate stripes type approach. So we used similar approaches you may have seen going around on the internet to look at how anomalous temperatures are for a certain area. So we use that to investigate the sea surface temperature anomalies in this region as well in this notebook. So it's quite a fun one, and I would encourage you to have a play with that. Once you've got the default version running, you can, of course, go back and change where the data is coming from. If you go back to the HDA functions, you can change the area, the time period, and you can look and see if you could identify marine heat waves in different areas. This particular notebook focuses on an example from later last year on around Hawaii, but marine heat waves are something that happens globally. So there's a whole variety of different notebooks there for you to work through and test. And I would also encourage you to have a go at developing your own. If you've already been working with Sentinel or Copernicus data in Python, see if you can get it to work using our WEkEO harmonized data access as well. Okay, thank you very much.
Thank you very much, Hayley. Very sorry, Laia, that we had technical problems. We are going to go to some question and answer sessions, and Marta is going to be moderating this session, so you can ask your questions through the chat, which you have already been doing all along the webinar. We are going to have a very short question and answer session, like about 10 minutes, but we will provide you with answers to all your questions through an email. Actually, we will collect all the questions and answer them through emails. You will receive an email in a couple of weeks with all the answers. Before starting the question and answer session, there were a lot of questions about how to access the Jupyter Lab. So maybe, Hayley, you could go through those slides. You're going to receive those slides just after this session, but Hayley is going to show you those slides which are summarizing how to access the Jupyter Lab.
Yep, I can do that, no problem. So I breezed through that. Admittedly, I'm sorry, it's quite quick. We've got quite a short time period today. But these are the slides that I mentioned that provide you with additional information about how to set up the Jupyter Lab environment for you to work in. So first of all, here's a bit of a reminder. If you haven't registered, you need to register to access the Jupyter Lab. So you can go to the user registration here. Somebody popped up in the chat and made a really good point. If you have any special characters in your name, you might struggle to register. I have this sometimes with my hyphen in my name, and I know other people do if they have accents on their names. So just consider that if you're having any problem with your registration. Once you're registered and signed in, you can go to the dashboard, which is at the top left of the screen. And you can click on that, and then you'll see that you have the option for clicking Jupyter Hub. Now, you then have several options that pop up. For the servers, we have to manage the resources behind the scenes. We have a certain amount of space that we can use for the Jupyter Lab, and we have obviously variable numbers of people who are using it. But you can choose one of these. Ideally, I would go for the expert mode, which gives you more memory. This may vary slightly depending on whereabouts in the WEkEO system you are at the time, but just generally go for the larger one, and you'll be able to get the most out of the notebooks. As I said before, the link here says Hub, but we're actually using a slightly more modern Jupyter Lab interface, but in principle, it's very similar. So the next thing to do is import the code, and I think this is what a lot of you were asking about. So from the first point of the Jupyter Lab that you enter, you have the launcher window. You can click on the terminal button, and that will open a terminal for you to work in. Then you need to type these commands. So you can type cd public. So this changes your current directory to the public folder, which is where this script, WEkEO clone git clone.sh, is held. You'll see that in the folder when you move in there. To clone the repository, you need to type then in the terminal bash wekeo-git-clone.sh. That's the script that we're going to execute. And then we have to type, there's a space in between here as well. You can just cut and paste this in, the link to the Git, so the GitHub, which is here. If you then hit the enter button on your keyboard, it will execute that command for you, and that will automatically copy the code over from our Git repository held on GitHub into your home environment on your Jupyter Lab instance. If you have any problems with the code or you want to ever take in a new version, you can go and run this same script. And you could also change the link here if you've got your own repositories that you want to try to bring into the environment. You'll then see this folder, as I said before, the WEkEO Jupyter Lab one will appear once you've executed that command. And then once you're in there, you can get started with the initial Welcome to Jupyter Lab notebook that I showed you. That'll give you your introductory information about how Jupyter Lab works and some hints and tips for managing the space well. And then you can go on to look at probably the best next step, to look at the WEkEO Harmonized Data Access example that I showed you before. That's located in this WEkEO-HDA folder that comes with this whole repository that you get. After that, once you've figured out how the HDA works, you can move on to the examples that I just showed, which are in the Ocean folder and then in the subfolders of Sentinel-3 and Ocean case studies. And each of those you can just click on, and it's set up so that all you need to really do is add in your user credentials, and you should be able to click through, and most things should run absolutely fine just with that information for you. But of course, if you have any problems, you can let us know through the chat forum that I'll provide the link for in a second. If you've done all of these and you're happy, you can try out some of your own code. You can edit the code that we've provided you to look at some different examples, different times, different data sources, etc. Try it and see what you can do. And of course, let us know. We really appreciate the feedback about how you're using the data and any problems you encounter, so we can improve your experience. On that note, there's some reminders here just about the size limitations. So you can have a look at within the Jupyter Lab environment, you have a bit of a limited space. Obviously, we can't give everybody huge amounts of resources all the time. We physically don't have enough infrastructure for that. But for this test environment, you've got enough to work with these notebooks. Some tips though, run one notebook at a time and clear the kernels in between. Tells you here how to do that by looking at the kernel menu at the top. You can also shut down kernels and terminals that you're not using. On the left of the Jupyter Lab environment, you have this little square in a circle. If you click that, it'll show you everything that's running. You can shut things down. That will help save some memory for you. And there's also a really helpful memory usage line in the bottom left corner of the Jupyter Lab, which tells you how much space you've used. So if you're loading in data and you see that you're starting to get towards the limit there, you may want to stop and rethink what you're doing, delete some extraneous data that you don't need, shut down other Jupyter notebooks you've got open, etc. And that'll help you manage the space a bit more efficiently. Once you've reached that limit, though, I would encourage you, if you think, okay, this is what I need to do, I want to test some things, have a look at the advanced plans, and you can move on to using some of the virtual machines that Michelle talked about. You can use this code already in those environments as well. And somebody asked earlier, can I use this code outside of the WEkEO Jupyter Lab? You can. If you've got a Jupyter installation on your local computer, the code will run as long as you've got the right libraries installed. Unfortunately, it won't work as fast as it will do within the WEkEO environment because we have specific infrastructure that allows us fast access to all the different data sources. The last bit here, getting help. If you have problems with access in general, you can contact the support desk, either through the web page here or through the email. And if you have questions about the Jupyter notebooks or anything else we've covered today, you've got there's a link here to a little chat form that will allow you to contact us, and we can answer your questions that you have about using the notebooks, about the data, whatever it is that interests you about WEkEO. Okay, thank you very much. You'll also receive these slides after the session as well. So again, this isn't the only time you'll see this information.
Thank you very much, Hayley. So now I'm going to leave the floor to you, Marta, for a 10-minute question and answer session. Thank you.
Okay, thank you for these clarifications about Jupyter. I think it will be very useful for everyone. And now we can go through the questions. Maybe we don't have time now for all of them, but as we said, we can reply them later, and we will send them written by email. So one of the first questions that we can try to answer right now is this one. For example, about processing tools available and the payment. So Stefania is asking about if we can give some example of processing tools available for satellite data available under payment, and if there are some tools for processing satellite data more than the ones available for free as Jupyter. So I don't know if maybe Hayley would like to answer this question.
Can have a bit of a go at this. So, I mean, there's a huge array of available tools for working with satellite data, and we don't provide anything specifically beyond the payment example that we don't provide automatically. Most of what we're working with is based upon open source software. So we can install, we have Jupyter, so you have access to all of Python, which is an open source library. For the virtual machines, we could install, for example, QGIS, we can install Snap, we can install various things that you want to use. So if it's freely and openly available, you can have it in your environment, whether that's, you've got a free test case or if you've got a more advanced offer. For other specialist software that might be licensed, I think we'd need to talk to individuals about that. I presume we could potentially have it in some way, but we need to check how that works with regards to licensing and payments, for example. We don't provide specific additional like processing software, like, I don't know, ArcGIS or anything like that as standard. Michel may have more to say about this as well if he's still here, but okay.
Thank you, Hayley. So more questions. So yes, about Sentinel-3 data. So is there a way to easily process Sentinel-3 radiance from OLSI to reflectance in the Python Jupyter environment?
I think this is probably another one for me. If you're just wanting to do the conversion that typically relies on a pi-based parameter, then you can just put it in simply as a conversion factor in a piece of Python code. That would be absolutely fine to do. I can share with you the methodology for doing that. We commonly do it when we're working with different types of data because the Sentinel-3 ocean color sensors don't record and process in exactly the same way as, for example, MODIS does and VIAS does. So we often have to make these into comparisons. So yeah, if it's a simple one-liner that you're wanting to do without any complex assumptions about, for example, the bidirectional reflectance functions, then you can do it. I think there's also some tools in Snap that will do this if you're looking at a slightly different way, if you're more interested in land data. Admittedly, that's not my area of expertise. You can't at the moment call those, for example, in the Jupyter environment, but if you're in a straight Python environment in a virtual machine, you could easily call Snap through the command line or use the graphical user interface when it's installed. I hope that answers your question.
Thank you. So the next question is not about data, but it's about these webinar activities. So Kandrasa is asking if participants are automatically registered for the next round of WEkEO webinar activity. Can you please, Laurence, clarify this?
Actually, this is a good question. I don't know. I think you are gonna have to register. Vincent, can you
Yes.
please confirm?
Yes. Actually, after this webinar session, you will receive automatically a thank you email where you will find presentations, all the presentations and the recording. And another email will be automatically sent to the participants to register to the round 3, to the debriefing session. And one more thing, during this afternoon, later this afternoon, I will send to all the participants all the material needed for your practical session at home. videos, tutorial videos, presentation, and recordings. You will have everything later this afternoon as well, plus an invitation to register to the debriefing session. Thank you.
Thank you, Vincent. Again, next question is more related about data. And Amadou is asking if the data sets pass through validation or if the data should be validated by the users.
I can probably take this one if you like.
Sure.
So the extent of validation varies a little bit depending on which data set explicitly we're looking at, but there's a lot of validation work that goes on in order to make sure that our products are the best they can be, and we're constantly trying to improve them. This goes for whether you're looking at data from the satellites themselves or whether you're looking at data from the services that are provided. So there's definitely a lot of validation that does go on. You can find out more about that in various publications. If you have a particular product that you're interested in, we can help you find that information. From the Sentinel-3 side, for example, we do our own validation within EUMETSAT, but we also work more broadly with the Sentinel-3 validation team. So this is a group of users around the world who do some validation themselves. So it's really a big community effort. Of course, validating satellite data over the entire globe, especially when we're talking about the ocean, is quite difficult because the ocean is really big and in situ data is expensive and rare. So this is definitely an ongoing effort. But if this is something you're interested in, I can point you in direction of much more information about how data is validated. For your own areas, if you have in situ data, I would very much encourage you to try and validate and check the quality of the data. And we love that kind of feedback. So please let us know if you do any validation work. Thank you.
Thank you, Hayley. So next question is about the plans and the offer. And Benoit is asking if there are plans that are fitting needs for PhD students with limited budget.
So actually, no, there is no plan for students, but you really have a few months free trial, which is going to be interesting for you. And all our pricing are very competitive with regard to other cloud processing capabilities. So I'm sure this is something you could afford within your PhD, because we have a plan which starts at €66 per month. I don't know whether, I hope this is something you can afford, but I mean, if you have any problem, tell us about it, but we have no specific plans for students.
Mm-hmm. Okay, thank you, Laurence. Next question now again is about the data, the availability of data for some areas. So I publish this one. Mirko is asking if does WEkEO have some data for Central Africa? And we also have another question about West Africa. So I think we can clarify if there is data for those areas.
So maybe, Hayley, you can complement what I'm going to say, but yes, we do have data over Africa, coming from the land service, and coming from Sentinel-3, Sentinel-1, and Sentinel-2, and Sentinel-5P. But I mean, the question doesn't mention which data they are interested in, so I cannot really answer more specifically. I mean, Hayley, do you have any other inputs?
Yeah, can add to that. I mean, so as Laurence said, it very much depends on exactly what data you're looking for. Some of the data streams are limited in the regions that they're processed. Sentinel-3, for example, covers the entire globe. So if you're looking for land-based data from Sentinel-3, atmospheric data from Sentinel-3 over land, you can get that globally. The same with the ocean. It's slightly different with Sentinel-2, for example, which has more of a, because it's a more land-based or land-focused mission, it covers the entirety of the land surface, but only covers a certain amount of the ocean in the coastal zone and around islands. So depending on what you're looking for, that would change. Sentinel-1, again, has a very different acquisition strategy depending on which of the data streams you're looking for from it. But if you're interested in a specific type of data, we can help you navigate and find if there's coverage from different sensors. The same, it expands with the services even more so. Certain products are only processed for certain regions because they have a regional application. But in general, where we can with Copernicus, we make the data globally open and available as much as possible.
Mm-hmm. Okay, thank you. The next question is about also the satellite data. In this case, if do we know which satellites can get more precise results near the coast? So maybe Hayley, would you like to answer this one?
As well. So again, it kind of depends a little bit on exactly what information it is you're looking for. If you're looking for sort of ocean-based parameters, such as information about chlorophyll biomass, then Sentinel-3 is a very good mission for this. If you're looking, it depends on whether you're looking for, start again, actually. There's a bit of a trade-off here always between several different factors when it comes to the satellite data, whether you want more precise data in time, in space, or in terms of, or precise or accurate, in time and space, or in actual accuracy of the measurements themselves. And depending on your application, those trade-offs will work out, I think, slightly differently for you. So if you're looking, for example, at a very, very tiny coastal inlet, then you might want to try using Sentinel-2 data, because Sentinel-3 data's resolution might not be high enough. But if you really want high precision sort of measurements that are based upon from instruments that are designed more for ocean-based measurements, then you might want to work with Sentinel-3. If you're looking for a very long time series of data in order to derive an exact trend, then you'll probably want to be looking at the Marine Service data, because then we have multiple satellites we brought together, which will optimize your coverage and the amount of time you've got physically to observe those phenomena and derive a more accurate result. So yeah, it's not a simple answer, I'm afraid. But again, if you have a specific application in mind, let us know through the chat, and I'll be very happy to help you work through what will be the best data for you.
Okay, thank you. I think that maybe we have some more time for maybe one or two more questions. So next question is about Jupyter notebooks in particular. And Jennifer is asking if we can use a standard Git commands in the lab environment to access other repositories or manage our own code.
Yeah, so this is a really great question. If you just want to import the code like I did today, then you can use exactly that script that we provided for you. If you want to then be able to also push back to another repository, it's slightly different because of how the Jupyter Lab is set up, and in terms of how the environment that you experience as an individual user is connected to the rest of the world and set up in the actual infrastructure we have. So you would need to basically reverse the process that's going on in that script. I've been working with the team behind the scenes, and I'm hoping we're going to be able to provide a script that will do the reverse soon. So you'll be able to push back what it is you're working on from your home directory through. You basically, if you look at the script, if you're quite familiar with sort of programming and the computational kind of infrastructure, you'll probably be able to figure out how you would reverse what you've done. You just need to move the data from your home directory into a temporary space where you can actually access out to the external Git repositories. So you can have a look at that, and we can update you on what we do to progress the use of Git in this environment. But yeah, personally, it's something I also value being able to do. So thank you for your question.
Mm-hmm. Okay, and another question related to data access, but in this case, in virtual environments is next one. Benoit is asking, how can we access the data that has been processed in the virtual environment for local use?
So I think I can talk to this from the Jupyter Lab perspective. So if you've downloaded anything to or created anything in your Jupyter Lab, when you're there, you can right click on it and download. I think you can also, within the command line, if you know your local computer details, you can send the data out in a more command line based way. We'd be able to figure that out for you with a bit of discussion. For things like your virtual machine, same goes. You can move out using, I think, general kind of SSH protocol. I don't know if Michel is still here, but he could probably talk more to that. In terms of just accessing data in general, as I said before, you can actually use the HDA from outside of WEkEO as well. So if you just want to download the data, you can do that to your own local machine too, to do your processing. You won't have the same fast access that we have within the WEkEO environment necessarily, but it does work outside as well.
Okay, thank you, Hayley.
Okay, thank you. I think we are going to stop here because it's 5 minutes after afternoon. So We've been together for more than 1.5 hours. It's plenty of new functionalities which are available through the WEkEO, so I can see that we have many questions. It seems that the Jupyter Hub doesn't really work for some of you, so we will try to fix that. We will try also to answer all your questions through emails. So we are very happy that you were all here today. Thank you for listening to Marta, to Hayley, to Michelle, and Laia and myself. Thank you to all the speakers. We will stop today's session here, but we will come back together on July 29. So as Vincent was saying, you're going to receive an email just after this session today afternoon. You receive an email with a lot of information, including all the videos, all the presentation, and also a link in order to register for the July 29 session, which is going to be in the morning as well, from 10:30 UTC +2. Meanwhile, we leave you with all these contents and Jupyter notebooks for you to work and practice so that we can come back together again on July 29 and debrief about all this. Thank you to all, and talk to you within 2 weeks. Thank you. Bye-bye.